going to continue on with some practice problems on how to represent patterns with tables and graphs, and so here we go. I'm going to do an equation or a rule that is showing y equals 5x, and maybe my paper said to show it in an input-output table. So I'm going to make a table, and remember, the variable that's all by itself is the output. So the output goes on the bottom. That's y, so then that means my input must be the x. I don't have any input numbers, so what numbers could I use? Eric? Mrs. McEnroe said if you don't know, you could always do yada yada yada. What? 0, 1, 2, 3, 4. So good job on remembering. 0, 1, 2, 3, 4. And then now what do I do? Hamza.
Look at the rule.
Look at the rule. This is the rule. Okay? And so if x is 0, 5 times 0 is?
0.
Okay? If x is 1, 5 times 1 is?
5.
If x is 2, 5 times 2 equals?
10.
If x is 3, we get the idea. There we go. If it said graph the data in the table, I know how to make a coordinate plane. We call this the x-axis. Call this the y-axis. Going up and down, right and left. We can use this information to create coordinates. X is always the first number, y is always the second number. So I have 0, 0. I have 1, 5. I have 2 and 10. Got 3 and 15. And I've got 4 and 20. And so from there, I would plot my point. 0, 0. 1, 5 over 1 up 5. 2 and 10. 10 would be pretty up high, so we'll just kind of guesstimate. And you get the idea there. On the STAR test, someone could say, well, what is the pattern? How do you describe this pattern? Is it additive or multiplicative? Someone I haven't heard from. Jeremy. It's multiplicative, and you know that it's multiplicative because when you look at the input to the output, whatever that pattern is, it has to work for every single one. So what is our pattern?
Times 5.
Times 5, and so it is multiplicative. Now, yes, you can see, oh, well, this is multiplying. But sometimes they don't always have that. Sometimes they just give you a table and you have to decide. Stop.